So I'm going to talk about a nonprofit I run. We kind of think that the world moves forward when smart people get in the same room and actually get something done. So we're trying to encourage that in our universities. And it kind of remains a mystery to us why that is not already the primary driver in universities. But so we've launched this thing called the Lander Challenge. The Lander Challenge, or Propulsive Lander Challenge, is a challenge aimed at pushing rocketry teams at universities around the world to build self-landing with the ground. And to give you an idea, we're talking about like 15 kilogram payloads. So think 15, 20-foot high rockets that are, this higher than this pedestal here, a couple hundred pounds. These are not small toy things at all. They're giving out, $15, $25, and $50,000 prizes. And we're pushing collaboration and kind of open sourcing everything as we do this. So we're open to actually go out 3 of each prize. I'll spare some of the more technical details, I think, for now, if it's a little short on time. But yeah, we've actually already got, I think the numbers are around 20 teams applying to Pursuit so far. Stanford, UC Berkeley, Purdue, UT Austin, UC San Diego, TU Unit even, and Manaf in Australia. So we have teams all around the world. And why the challenge? So challenge competitions actually enable students to sustain focus. This is kind of a weird thing. If you haven't been a part of an engineering team or something similar to schools, you might not have run into the thing of every 4 years, your team is entirely new people. And this makes knowledge transfer or sustaining a goal of any kind extremely difficult. The person who sets the goal leaves the team oftentimes after 6 or maybe even just 12 months on the team. Yeah.
This is a very underrated problem that is not really faced in many other places in life, at least that I know of. So that's why you see these like Formula Student or these other Space for America Cup you might have heard of. That's why these things are really, really successful. It's very hard to get young people to be able to sustain something because the leaders leave. Number 2, future of space is pretty clearly in reusable vehicles or some other similar things. But right now we're seeing a lot of VTVL progress. So why don't we have students working on this now? When we first got started, I spent, I think, 2 or 3 months talking to everybody, and everyone was like, this is impossible. Nobody can do VTVL at the collegiate level. That's just not possible. No one's ever going to throttle a liquid engine. That's not going to happen. Well, Berkeley did in November of last year. So it's very possible. We have lots of teams that are now going after this. And I'll show you later, we have a bunch of people involved who did this professionally for 40 years and can attest that this is actually quite tractable. Better progress through fast iteration. This presentation was originally tailored towards some teams I was speaking to, so some of this tailored to them. But right now, a lot of these student teams are working on this Kármán line challenge where they're all trying to get to space. This sounds great, but it's actually quite dumb as a goal to set because you are trying to build these massive engines that take students 3 years to design, and by the time they're built, the students who designed them are now working at SpaceX or something else. So we are trying to get them to build smaller engines that are more complex, right? There's a lot of companies that are building 500, 700 pound force engines for a long time. There's student teams who've hot fired 8,000 pound force engines. This is like very cool, but at what expense sometimes? So last thing is exciting and tractable. We actually think this can be done, and we think this is like really cool. I mean, a lot of these teams are anywhere between 20 and 200 members. There's a couple European teams that are in the 400s. But I think if you put up flyers around campus with a self-landing rocket, you get some more interest. So this is a bit about kind of our leadership team. A lot of us are ex-engineers, a lot of engineering background. Myself and Mana were on Georgia Tech's rocketry team previously. Some of our volunteers is Ursa Major and previously SpaceX. We've got some safety people. You guys, I don't know if anyone in here recognizes any of these people. Mark Holthaus is one of the directors at FAR, which hopefully some people have heard of, Friends of Amateur Rocketry. It's like the legendary amateur rocketry site in the Mojave. All sorts of crazy history was made at FAR. It could not be understated. Madison's originally was from Virgin Orbit. Madam Trampour, who's involved in writing the rules for basically every aerospace competition that exists, and nobody knows it. It's really funny. We've got some other people you might recognize, like Michael and Colin from Mast and Space Systems. You guys might recognize Joe Barnard from BPS Space, some of the people that have been really supportive in helping us get early funding and things like that. And we got some partners here. So we're supported by Impulse Space, which was Tom Buller, who was the propulsion CTO at SpaceX for a long time, left to start this company. Stoke Space, which I personally think is really cool. Stoke Space is trying to go 100% fully reusable from day one. I sometimes do a little bit too much PR for them. I think when I first got on a call with them, the kind of sponsorship partnership lady was a little freaked out by how excited I was about them and trying to get them involved. She was like, "What? You guys seem a little overly sold." But And we're also, of course, partnering with Foresight, FAR, Astrobotic, and the Spaceware Company. A lot of people probably know Masten Space Systems here. Is anyone familiar with the Northrop Grumman Lunar Lander Challenge? I'm sure at least a couple people. So that was where the first, pretty much the first kind of private vertical landing vehicles were developed. And Masten Space Systems was one of the companies to come out of that. And they just got kind of acquired, we'll say that, by Astrobotic now. So kind of happy to have some of those guys involved, which is pretty cool. And yeah, I'll talk a bit more about some of the problems we're working on. How much time do I have left here? How much should I talk?
1 minute 40 seconds.
Okay, I'll speed through this. So we've ended up spending a lot of our time trying to solve various legal hurdles or other problems facing these teams that these guys don't have the experience or whereabouts or tractability to solve. Shockingly, universities don't tend to be that helpful towards these guys. They go and ask a legal question, the university says, not our problem, go away. Very unfortunate. I'll speed through some of this. Knowledge transfer is a big deal, actually. I'll talk a bit about this. These guys all keep secrets from each other. They don't share what they're doing. And then they all go work at SpaceX together. Makes no sense. We're making a centralized platform. It's a Confluence page right now where everyone has to open source everything they're doing in this challenge. Every CAD, every detail. It's an ITAR nightmare. It's very fun. More points on collaboration here. We want them in each other's design reviews, that kind of level of collab. ITAR, I'll gloss over this for now, but long story short, actually a lot of this is legal. Everyone assumed it was illegal. I don't think it makes sense to get too much into this. Insurance. Getting insurance for these teams so that if they hurt themselves, they're covered is surprisingly difficult. So we're working on that for them as well. And I'll go through one other thing at the end, which is something we're super excited to share that has been secret for a very long time, which is that we're actually planning to build a $1 million rocket lab at Georgia Tech to support some more stuff like this going on. So we just secured funding for that a couple weeks ago, and we just kind of started working with them to make that happen. So we're super excited about that. And then last slide here, how can I help? We're always raising money. We're a nonprofit, and we're also looking to hire a program director to really run the challenge at its core. So I would love to talk to or meet anybody who might know someone who'd be interested, or if you might be interested. But yeah, I think a lot of the stuff we're talking about here today is either far off or in the future, or nearby maybe. But these are the people who are actually going to execute on a lot of these visions, and we're pretty much doing nothing to actually prepare them now. Right? There's very few places you can go to actually get some of these people in a room doing something together with some sort of result of any kind, much less a novel result that isn't just repeating what last year's students did. So I can't personally understate the importance of stuff like this. But yeah, I think that's it for me.
Thank you. And again, we have time for a question or so. My Grace in the back.
I'll get it.
Thank you.
Sorry. I had to sit in the worst place. I think it's awesome to build an online repository of rocket motors. I think it'd be great. I do think the ITAR people are just going to shudder at that, but I think it should be done. Have you thought about maybe seeing if any commercial company that's been working on motors for a while might be willing to just license it for academic use, or push it to you guys so you have something that's small, that's been flown a lot already, and that's relatively simple that you could just pass off to students? Because I have to say, actually, I feel like building a big fat solid to go to the Kármán line, to me, actually sounds easier than what you're describing, not the other way around. But that sounds hard. You have to control a thing and have it not explode. That's tough.
Yeah, it's actually ends up being harder because of just finding a place to launch ends up costing teams like 200 grand. So a lot of the teams are running into the length of timeline just to develop an engine turns out to be much harder. This is kind of one of the original, I don't know how I can explain this quickly, unfortunately, but the short example is if you talk to anyone who's done both, they'll almost all agree it's actually easier. Because you can think, I can go out on a weekend, just like Masten did, hang an engine or a rocket from a forklift and fire it, stop, upload code, fire it again an hour later.
No FAA approvals.
No FAA needed at all because they literally don't care unless it can hit a city. That was actually the first thing we were worried about. We got started and it was like, the FAA is not going to go for this. We got on a call with all of the approval offices in America, and they were like, this is fine, we don't care. We have no reason to jurisdiction over this. The other part of your question about giving motors out, this is actually a really common question. So these teams are designing and building their own liquid engines from scratch. If you go to them, even with a liquid engine for them to use, they just don't care. They have no interest in your liquid engine. They want to design and build their own. Yeah, this is great for the kind of elite end of teams. But yes, one of our funders has been talking to us about trying to, I'm telling him after we are finished with the first thing on our plate, build a more scalable single engine to go to hundreds of teams to get them to this stage.
Stock racing.
Say?
It's like stock racing.
Yeah. But unfortunately, these guys are like at the cutting edge. They're not interested. Most of these guys scoff at solids in general, whether you like that or not. They're not interested in anyone else's liquids. But
Thank
it's
you.
a good next step, I think.
Awesome. What is your challenge for folks here?
I think maybe word this better, but how to put ambitious young people in a room together to get somewhere on some of these problems. So how would you word that?
How do we onboard?
Yeah, how do we get groups of young people to make progress on some of these issues, and not fake progress where they go through how to drop an egg with toothpicks, but some sub problem that really matters.
Okay, wonderful. Well, thank you so much, Patrick. This is great. Awesome.